So now we go for third method, which is about linear differential equations. Okay, so we define like this: a differential equation of the form dy by dx is there, that means it's a differential equation, plus p into y equals to q, where what about p and q, where p and q are constants भी हो सकते हैं और expressions of variable x only, expressions of x, functions of x. Expressions means what? Functions of x, remember. So what we have written? A differential equation of the form dy by dx plus p into y equals to q. I repeat, a differential equation of the form dy by dx plus p into y equals to q is called linear differential equation, is called linear differential equation, remember. So that standard form you need to keep in your mind. What's the standard form? dy by dx plus p into y equals to q, where p and q क्या है? Constant भी हो सकते हैं और expressions of x भी हो सकते हैं, remember. Like this, if I give some example here, dy by dx plus x square into y equals to 2. So this is a linear differential equation. अब देखो, here p is x square, this is p, and what is q? That's constant. Coefficient of y is x square and right hand side is here, that's p, and right hand side is q. Remember, dy by dx का coefficient यहाँ पे 1 है, कुछ भी नहीं है. If I ask you, is this linear differential equation x square into dy by dx plus x cube into y equals to, let me write 3. The answer is yes, this is a linear differential equation. Then immediately next question comes to in our mind, what is p? Now if you write p equals to x cube, it's wrong, remember. P is coefficient of y, but remember coefficient of dy by dx should be 1 here. That means I need to divide by x square. So dy by dx plus, if I divide by x square, this is just x into y equals to 3 by x square. So now this represent p, remember. अगर आपने डायरेक्टली p बराबर x क्यूब लिख दिया तो it's wrong, remember. And what is this? This is nothing but q, remember. Okay, so p is x, here q is 3 by x square. यहाँ पे q constant था, this is expression of x. Fine. Okay. Now two things we notice here about standard linear differential equation. Number one is y का exponent 1 ही होना चाहिए, right? Two things. Number one, right? We observe about this standard differential equation. Number one, exponent of y should be 1 always. Exponent or the power of y equals to 1 ही होना चाहिए. अगर यहाँ पे y square आ गया तो it's not a linear differential equation, standard linear differential equation. And y and dy by dx should not be in the product. Y into dy by dx नहीं होना चाहिए. This should not be there in a standard linear differential equation. Why I'm emphasizing on standard linear differential equation, I'll tell you. But this is a standard linear differential equation. Dy by dx into p into y equals to q. I repeat, dy by dx plus p into y equals to q, where p and q can be constants or expressions of x, as I given two examples. One more thing, that is, in a standard linear differential equation, y square नहीं होना चाहिए, remember, 1. And y and dy by dx should not be in the product. ऐसा नहीं होता है standard linear differential equation. Fine. Now, once you have this, right, then we write its solution. It has proof also, but here we have ready solution. So I'll write here solution of linear differential equation. Solution of linear differential equation. Linear differential equation. Solution of linear differential equation. We have ready formula, but before I write the solution, we need to find one factor which is sometimes called integrating factor. Integrating factor, which is sometimes called just IF. In MCQs it can be asked just get IF. What is integrating factor here? That depends upon P here, remember. The integrating factor, I'll just write, you can refer the textbook why this. Here it is given by e raised to integral of P with respect to x. This is called integrating factor. It requires to solve the differential equation, but here you have direct e raised to integral of P, remember. And now solution is given by this formula. So you just need to remember this formula. Solution is given by y into integrating factor equals to inside the integral q into integrating factor the whole integral and plus the constant of the integration. This is the solution. Ready formula for you. Nothing you have to think. Just you have to find correctly what is P and what is Q. Solution is given by which formula? Y into integrating factor equals to inside the integral q into integrating factor plus the constant of the integration. I repeat, solution of the linear differential equation is given by this expression. What's the formula? Y into integrating factor equals to inside the integral integrating factor q into integrating factor plus c, the constant of the integration. Now, okay, so here this is over, but sometimes we may have differential equation of this form. Differential equation of this form. What I'll do in the standard linear differential equation, I'm just interchanging variable dx by dy. Remember, plus here p into, there we were writing y, here we write x equals to q. This is the corresponding linear differential equation. ये भी linear differential equation, बट यहाँ पे variable interchange हो गई. What about p and q? वहाँ पे क्या था? Constants or functions of constant or function of or expression of क्या लिखा था? You had written x, तो here y. Where p and q are expressions or functions of y or constant. Fine. नाउ यहाँ पे देखो, यहाँ पे x का हाईएस्ट पावर 1 होना चाहिए. ये दोनों सेम होता है, इतना याद रखो. अगर यहाँ पे x तो यहाँ पे भी x. कीप इन योर माइंड. यू सी देर दिस वाज y तो यहाँ पे भी y. ये दोनों का, इसका पावर 1 होना चाहिए, ये दोनों प्रोडक्ट में नहीं होना चाहिए. इसका पावर 1 होना चाहिए, ये दोनों प्रोडक्ट में नहीं होना चाहिए. नंबर 1. व्हाट इज इंटीग्रेटिंग फैक्टर हियर? IF. आपको वही माइंड में रखना है. ई रेस टू इंटीग्रल ऑफ पी डी एक्स था, यहाँ पे पी डी वाई आएगा. इंटीग्रेटिंग फैक्टर इज गिवन बाय व्हाट? ई रेस टू पी डी एक्स. एक ही याद रखो, जस्ट वेरिएबल इंटरचेंज करो. डोंट मेमोराइज बोथ, अदरवाइज यू विल गेट कंफ्यूज्ड. सॉल्यूशन माइंड में वही रखना है. सॉल्यूशन, व्हाट्स द सॉल्यूशन? दैट इज y इंटू, तो यहाँ पे आएगा ये x इंटू इंटीग्रेटिंग फैक्टर inside the integral q into integrating factor dx था, यहाँ पे क्या लिखेंगे? You will write the dy plus c. You have just interchanged the variables. This is called the corresponding linear differential equation, right? If it is not the standard one, you may have sometimes this form also. Remember, we have such questions, you will see. Don't remember this, वो स्टैंडर्ड ही याद रखो. and based on that standard differential equation आपको ये लिखना है. I repeat, स्टैंडर्ड था dy by dx plus p into y equals to q. यहाँ पे इंटरचेंज किया dx by dy plus p into x equals to q. p and q are functions of y, remember, इसलिए आप इंटीग्रेशन विथ y करते हैं. यहाँ पे, वहाँ पे फॉर्मूला क्या था? e raised to p dx. यहाँ पे क्या होगा? e raised to p dy. a याद रखो, इंटरचेंज द वेरिएबल. सॉल्यूशन था y इंटू इंटीग्रल ऑफ इंटीग्रेटिंग फैक्टर, सॉरी, y इंटू इंटीग्रेटिंग फैक्टर q इंटू इंटीग्रेटिंग फैक्टर विथ रिस्पेक्ट टू x. यहाँ पे क्या होगा? इंटरचेंज द वेरिएबल x इंटू इंटीग्रेटिंग फैक्टर q इंटू इंटीग्रेटिंग फैक्टर विथ रिस्पेक्ट टू y प्लस c. That's what all in all about linear differential equations. Remember, we now go to next exercise, one of the simplest exercise of this chapter. Remember, there is nothing. Immediately you will be having the question of integration. आपका इंटीग्रेशन चालू हो जाएगा एक ही स्टेप में. सो यू मस्ट हैव कमांड ओवर इंटीग्रेशन, एज आई कीप ऑन टेलिंग यू सिंस लास्ट 2 months. Okay, so here exercise 9.6. Exercise 9.6. The question is, for each of the differential equation, find the general solution. So question number 1 here, solve this differential equation. dy by dx plus 2y equals to sin x. Now देखो एग्जाम में दे एक्चुअली दिस एक्सरसाइज इज बेस्ड ऑन लीनियर डिफरेंशियल इक्वेशन, वो आपको पता है. बट एग्जाम में लोग बोलेंगे नहीं. सो यू नीड टू नो कि भाई ये वेरिएबल सेपरेबल से होगा, होमोजीनियस से होगा या लीनियर डिफरेंशियल इक्वेशन से होगा. वो आपको पता चलना चाहिए जस्ट बाय ऑब्जर्विंग द इक्वेशन. देखो इसमें वेरिएबल कभी भी सेपरेट नहीं होगा. यू कैन ट्राई. सो इट कैन नॉट बी सॉल्व बाय वेरिएबल सेपरेबल मेथड. ए होमोजीनियस भी नहीं है क्योंकि यहाँ पे y का पावर 1 है, ये तो साइन के साथ है. सो दिस इज नॉट होमोजीनियस. So this is a linear differential equation. Linear differential equation. Not only linear differential equation, but it's a standard linear differential equation. So what is P? Coefficient of y. ये दोनों same होना चाहिए. 2. What is Q? Sin x. Immediately we'll get integrating factor. इसका coefficient 1 होना चाहिए. Don't forget that. Integral of P with respect to x. P dx. E raised to integral of 2 with respect to x, that is e raised to 2x. You know 2 will come out, integral of 1, that's x. Now I'll write directly. Solution is you have prepared formula y into integrating factor, inside the integral q into integrating factor the whole dx, and at the end we are going to write what? Plus c. So here y into e raised to 2x equals to, what about this? Q. Q क्या है? Sin x. So sin x into e raised to 2x here dx. So कहाँ पे क्वेश्चन आके अटक गया? इंटीग्रेशन ऑफ दिस. इसका इंटीग्रेशन आपको करना पड़ेगा, राइट? हाउ विल डू दिस? आई विल नॉट डू दिस. डू इट बाय पार्ट्स. कितनी बार करना पड़ेगा? यू माइट हैव रिकॉल. 2 बार करेंगे तब आंसर आएगा. अंदर वापस आ जाएगा. एंड चेक योर आंसर. सो सम इज ओवर. यू कैन डू बाय वन ऑफ द शॉर्टकट फार्मूला ऑल्सो. सी आई एम डूइंग बाय दैट फार्मूला. आपको बाय पार्ट्स 2 बार करना पड़ेगा. इसको आई बोल के सेपरेटली करो. मैं डायरेक्टली लिख रहा हूँ y इंटू ई रेस टू 2x. इसका इफ़ यू रिमेंबर ई रेस टू 2x अपॉन ए स्क्वायर प्लस बी स्क्वायर, दैट इज हियर 4 + 1. देन हियर 2 इंटू साइन है तो पहले साइन x लिखो. फिर b1 है, बीच में माइनस होगा. 1 इंटू कॉस x लिखना आपको, राइट? प्लस c. आई डिड इट डायरेक्टली, रिमेंबर, प्लस c. सो यू कैन राइट हियर y इंटू e raised to 2x equals to e raised to 2x by 5 2 sin x minus cos x plus c. That's required general solution. क्यों इसको जनरल सॉल्यूशन बोलते हैं? आर्बिट्री कांस्टेंट है अंदर, इसलिए एक है. ऑर्डर भी 1 है, इफ यू रिमेंबर बिगिनिंग ऑफ द चैप्टर. सो दिस इज रिक्वायर्ड सॉल्यूशन, राइट? जस्ट हैव अ लुक ऑन द बैक साइड आंसर. रिमेंबर हियर आई रोट डायरेक्टली. डोंट डू दिस. एक फॉर्मूला से आए, फॉर्मूला भी आपको बताया वाई दिस. You can do this in MCQs, but in subjective you need to use integration by parts, remember, twice. Fine. I hope this is very simple for you. We go to next question. Question number 2. Second question. Let's go to question number 2. dy by dx plus 3y equals to e raised to minus 2x. Ask yourself, is this linear differential equation? Compare with which one? dy by dx plus p into y equals to q. That standard form should be there in your mind, remember. So what is p here? P is 3, which is constant. What is your q here? E raised to minus 2x, right? So first task is integrating factor. e raised to integral of p. p कितना है 3, so 3 will come out, it is just e raised to 3x. Right, now we write the solution. What's the formula for solution? You know the solution is given by which formula? Just recall, ये standard है इसलिए क्या होगा, y into integrating factor. I'm writing directly, you should write that step. Inside the integral q क्या है, e raised to minus 2x into integrating factor 3x. Okay, so y into e raised to 3x, this is just e raised to x. And what is the integral of e raised to x? That's e raised to x plus c. Right? If you want, you can write one more step. You can divide by e raised to 3x. So y is equal to e raised to minus 2x plus c times e raised to minus 3x, which is a required solution. Normally we express in form of y equals to something. So this is your required solution. What I did, dividing by e raised to minus 3x. So e raised to x upon e raised to minus 3x. You have this, c into e raised to 3x equals to this. Fine? I hope this is clear to you. So it's so simple. Just use integration. Fourth question, third you can try. In third question, p is 1 by x. Remember, let me do that, no problem. Third one, dy by dx plus y by x equals to x squared. So this is a standard linear differential equation. Remember, linear differential equation. देखो y का exponent 1 ही है and y and dy by dx are not in product. What is p? Coefficient of y, 1 by x. What is q? That is x squared. Expression on the right hand side. What you need to keep in your mind, dy by dx का coefficient 1 ही होना चाहिए, otherwise आपका p and q wrong आएगा. What's integrating factor? E raised to integral of p, e raised to 1 by x dx. What's this? This is nothing but the e raised to log of x. We are not writing mode here, I'm just writing x. आप ये जानते here base is always e, so here by composition this is one of the property, your final answer is x. आप जानते a raised to log x to the base a is always x. You have used this property in differentiation, remember, number of times. 2 raised to log x to the base 2, the answer will be this number only. ये दोनों bases same होना चाहिए, you know it from differentiation. So here it is just x. Now we write solution is here. Solution is, what's the solution? Y into integrating factor equals to, inside the integral, q into integrating factor, the whole dx. What is the integrating factor? Here x. What is q? That is x squared into x, the whole dx. So therefore, now it is very simple to integrate. Xy equals to, this is just x cube, and what's the integral of x cube? X raised to 4 by 4 plus c. That's a required general solution. This is a required solution, general solution, because the c is arbitrary constant, you know. Okay, as far as fourth question concerned, there I'll just write for you only. You can see that the p is sec x. And what is q? That's the right hand side expression, which is 10x. Just observe question number 4. What is the integrating factor? E raised to integral of sec x. Right? Do you remember integral of sec x? Sec x and cosec x. What's the integral of sec x? You know it is log of mode of sec x plus 10x. I'm ignoring mode here. Log of mode of sec x plus 10x. So here if I use that property, you will get just sec x plus 10x. Right? That e raised to log to the base e will get cancelled and you are left with just this one, as I've used in the previous case. Now you write just solution is here y into integrating factor. So you have this equals to, inside the integral q, which is 10 into this expression the whole dx, and now this, just to open the bracket, both will be standard forms and you can integrate it. So in the sixth question here, x into dy by dx plus 2y equals to x squared log x. Now this is a standard linear differential equation. If I divide by x, so this is 2 by x into y equals to x log x. It is in which form? You can just recall dy by dx plus p into y equals to q form, remember, right? And therefore, what is p here? 2 by x. What is q here? Expression on the right hand side, x log x. P means coefficient of y here, remember. Okay, now we write the solution. Before that we need integrating factor, e raised to integral of p. So you have e raised to 2, I'll keep outside, it is just 1 by x dx. Now what is this? This is e raised to 2 times log x. Now you can cancel this 2 if the coefficient is 1 here. So what I'll do, I'll take this 2 in the power. So you have e raised to log of x squared to the base e. Now this will get cancelled. So you have just x squared here. Fine. And now solution is given by here. Solution is, what is the formula? Y into integrating factor equals to inside the integral q into integrating factor the whole dx. Y into, what is integrating factor? X square. Q, what is q? That is x log x. And integrating factor is x square here, remember. So let me write x square dx. So you have y into x square. What about this? This is nothing but log x into x cube. Now this is a very basic question of integration. How will do the integration on the right hand side? Product of two functions. Recall Liet rule and use integration by parts. Logarithmic becomes u, remember, and this is v, right? Do by parts. Not a difficult task. I hope you can do this much now. Okay, so I leave it for you and just compare with the backside answer. Okay, next question number 7 here. 7th question. There you can see that the coefficient of dy by dx is x log x. So I'll divide by x log x. So next step for you is this, dy by dx 1 upon x log x into y equals to, you have that log will get cancelled, but you have 2 by x squared. Just check it out. Q will be this. Dividing by which expression? X log x, because the coefficient of dy by dx should be always 1, remember. Here x will get cancelled and by x gives us x squared. So what is p? 1 upon x into log x. What is q? 2 by x squared. This is linear differential equation. What's integrating factor? E raised to integral of p. So you have e raised to 1 upon, you have x into log x dx. How do we integrate this? Every time, have you noticed, question comes to basically where integration only, remember. So you must have good command over integration. You know such question, isko upar le lo aap, so this become 1 by x upon log x, or you can put log x equals to t if you don't want to do this. So e raised to, you know now this is f dash upon f form. So you have log of mode of denominator expression, if you remember. Log and exponential will get cancelled, so your final answer is just log x. This is nothing but integrating factor, remember. If you want, you can write here modulus x also. Okay, now solution is given by which formula? You can write the formula y into integrating factor. I am writing here directly log x equals to inside the integral q. What is q here? That is 2 by x squared into integrating factor, which is log x into dx. I repeat, what's the solution here? Solution is given by y into integrating factor equals to inside the integral q. What's q? That is 2 by x squared into integrating factor, that is log x here, dx. Now the question is, we need to integrate right hand side expression. Now how we'll do this integration? Again, product rule. Log is always u. Take 2 outside. This is just v, remember. So we'll do by parts on the right hand side using Liet rule. So here y into log x as it is. Log x 2, you can keep it outside here. Log x will come out into integral of 1 by x square. You can just recall it is minus 1 by x. By which formula? 1 by x square means x raised to minus 2. So integration will be minus 2 plus 1 upon minus 2 plus 1. And this is nothing but just minus 1 by x, which I wrote here directly, remember. This is minus 1 and this will come down. Minus inside the integral differentiation of log x 1 upon x into derivative of 1 by x square. So same here, minus 1 by x, so I'll write here plus 1 by x dx. And therefore now y into log x equals to minus 2 times log x upon x. This 2 will go inside. This is 1 by x square. As you have written here, this is minus 1 upon x plus c, remember. Right? Just look at the expression carefully. 2 will go inside, so 2 log x by x. Here this is nothing but 1 by x square. And what is the integral of 1 by x square? Minus 1 by x, remember. Plus c. C is the constant of the integration. If you want, in the last step here, you can just take again 2 by x outside with minus sign. So you have log x here and this is plus 1 plus c. This is a required solution here, remember. This is a required solution. Right. Okay. Now next, in the 8th question, if you just look at it, question number 8, there you need to express in which form? Dy by dx plus p into y equals to q form. So that you can do, I'll just leave it for you, not a big task. I'll go for question number 9. There you x into dy by dx plus y minus x plus xy into cot x equals to 0. Now when such question is asked in the exam, you can see whether you can do by homogeneous differential equation or linear variable separable or not, and then you can decide whether homogeneous is useful or not. So here it's not homogeneous. Here 1 1 1, but here 2, so it's not homogeneous. Variable separable se bhi difficult hoga, so I'll try to express in linear differential equation form. So ये दोनों में से y कॉमन आना चाहिए. You know what is linear differential equation form. Into y, dy by dx plus p into y equals to q. So I'll take x on the other side. Coefficient should be 1, so I'll divide by x now. So here you have 1 upon x plus here cot x into y equals to 1. Now it is in which form? Dy by dx plus p into y equals to q form, remember. Okay, what I did, just taking y common. So you have this 1 from here and x cot x from here, dividing by x. So here 1 by x cot x, and this is just 1. What is p here? 1 upon x plus cot x. What's q here? 1, remember. So now do it. You can do it, I'm sure. Now look at it. Question number 10. You see there, you have x plus y into dy by dx equals to 1. The question is this standard linear differential equation? The answer is no, remember. If you just recall the first slide, there I already told you that the y and dy by dx should not be in the product. देखो, if it is the standard, ऐसा नहीं होना चाहिए. यहाँ पे है, देखो, observe. So this is not the standard linear differential equation, remember. Is this that corresponding linear differential equation? Let's see. So x into dy by dx plus y into dy by dx equals to 1. Fine. Now you already noticed that this is not the standard linear differential equation because a product में. So this step I wrote just for your information. Now we get into the other form. दूसरा form में हम लोग express करेंगे. So there you have, you know, dx by dy. So I'll take this one over there. dx by dy equals to, you are left with x plus y. आपको पता है यहाँ पे x है तो बाजू में भी x दिखना चाहिए. So dx by dy, I'll take this one over here, minus x equals to y. This is a good example, remember. Now this is in which form? dx by dy plus p into x equals to q. That the corresponding linear differential equation. Is it? It is in this form. So what is your p here? Minus 1, remember, coefficient of x. What's your q? Expression on the right hand side. This is that corresponding linear differential equation, remember. Fine. P is minus 1, coefficient of x. Q is RHS expression. It will be in form of y, remember. So here integrating factor आपको एक ही याद रखना है, e raised to integral of p with respect to x, but here with respect to y, remember. So minus 1 dy, so we'll get the e raised to minus y. Fine. Now solution, you keep the standard one in your mind. Solution is given by, what's the formula for solution? Just recall, y into, so here you have x into integrating factor equals to, inside the integral, q into integrating factor into, there you have dx, so here dy. Place the value, x into integrating factor, e raised to minus y. Q, what was q? That is y. E raised to minus y dy. Now वापस कहाँ पे आ गए आप? इंटीग्रेशन पे. This is again right hand side integration. How will do the right hand side integration? By parts. It's a product of two standard functions. कौन से दो standard functions है? Just observe it. Exponential and algebraic. Exponential function is the last. So this will be v and this is always u, remember. Exponential is the last function. So I'll do by parts here. If I do by parts, left hand side as it is, remember. So here x into e raised to minus y as it is. U will come out. How do we integrate e raised to minus y? Coefficient of this is minus 1. So upon minus 1. All these things you know, remember. अगर आप नहीं जानते तो you need the practice of integration. Derivative of y with respect to y, that is 1. Integral of e raised to minus y, जो यहाँ पे लिखा वही आपको यहाँ पे copy करना in the whole dy. So finally we have minus y into e raised to minus y. Minus minus will be plus, and one more time integration of this, that is e raised to minus y upon minus 1 plus c. So finally you will get here x, I'm just dividing by this, x equals to minus y, here just minus 1 plus c into e raised to y. What I did, just dividing by this throughout the equation, dividing by this much. So ax, a minus y, and if you divide by this, actually it will be here like this. It will be c upon e raised to minus y. So it becomes c into e raised to y, and therefore x plus y plus 1 equals to c into e raised to y. This is required solution. It's a good question. Fine. Now question number 11 and 12 वो तो देखने से पता चल रहा है क्योंकि दोनों में y squared है. Standard differential equation never contains y square, remember I already told you. But the previous question 10th में confusion क्या था? There was y also, remember, but y and dy by dx were in product, so you cannot do by standard linear differential equation method. Question number 11 and 12. In these two questions, you can see there is y squared. Standard differential equation never have y squared, remember. So, these two questions are also important. 11 and 12, both are important. I'll do one of these two. Let me do the 11th. Okay. Y into dx plus x minus y squared into dy equals to 0. Right? Have you noticed that this is not the standard linear differential equation? That's the corresponding linear differential equation. So immediately that standard form should be in your mind. What's the standard form? Standard form आपके mind में आना चाहिए. So ये हमारा form हो गया dx by dy plus p into x equals to q. We need this, remember. This is that corresponding standard form. So I need dx by dy. So you have y into dx by dy. I'll take both of these on the other side. So, or let me write over here, no problem, equals to 0, right? Dividing by dy. So dy सब divide कर दिया आ गया. Okay. Now coefficient should be always 1. So dx by dy plus dividing by y. 1 by y into x equals to, here your y square by y, dividing by y, remember, dividing by y, remember. You know why this? Because coefficient should be you know 1 only, that you know. Okay, now it is in the standard form. So what is your p? 1 upon y. What is your q? That's just y square by y. This is just y. Integrating factor, you know, e raised to integral of p dx, but here p dy. So e raised to integral of p. What's p? 1 upon y dy. What is this? You know, log of mod of y. Log and exponential will get cancelled, so we are just getting y here. I'm ignoring modulus. I wrote just y. Now go to the solution. IF मिल गया आपको. IF is this. Now what's the solution? आपको standard ही याद रखना है. क्या है standard? Y into integrating factor. तो x into integrating factor equals to q into integrating factor the whole dx. यहाँ पे dy होगा. Therefore x into what's IF? That is y equals to q. क्या है? वो भी y है. Q is y. What is IF? That is again y into dy, right? So you are getting this in the 11th question. Okay, so therefore x into y, this is y squared. What's the integral of y squared? Y cube by 3 plus c. If you want, you can write one more step. X equals to y squared by 3 plus c by y. This is required solution. Required. You could have kept in the previous step form also. A भी आपने रखा होगा तो भी right होता. Remember, don't worry about it. Doesn't make much difference. Fine. Clear? So simple. Try for 12th. Okay. Now I'll go for question number 14. 13, 14 and 15. These are about particular solutions. So let me do that question. Question number 14 I'll be doing. Same thing, but आगे आपको particular solution चाहिए. So question number 14 here. There you have 1 plus x squared into dy by dx plus 2xy equals to 1 upon 1 plus x square. Now question is this standard linear differential equation? The answer is yes, it's a standard linear differential equation. Why? Because here you can see that y का power 1 है and x into y into dy by dx product में नहीं है, but coefficient 1 चाहिए, so I'll divide by 1 by x square, 1 plus x square. So 2x upon 1 plus x squared into y equals to 1 upon 1 plus x squared, the whole square. You are dividing by this, remember. So therefore what is p? 2x upon 1 plus x squared. What is q? 1 upon 1 plus x squared, the whole square. Fine. So now you need integrating factor. Integrating factor, remember. What's the integrating factor? E raised to integral of p with respect to x. इसका इंटीग्रेशन ये ऑलरेडी एफ डैश अपॉन एफ फॉर्म में है, सो इट विल बी लॉग ऑफ मोड ऑफ डिनोमिनेटर एक्सप्रेशन. इसका इंटीग्रेशन, दिस इज ऑलरेडी इन विच फॉर्म? एफ डैश अपॉन एफ फॉर्म, रिमेंबर. सो आई रोट डायरेक्टली दिस. And what is this? This is just 1 plus x squared. Now we have used number of times. Base is e, or log and exponential will get cancelled. Okay. So now formula for solution. Here y into integrating factor, I'm writing directly, I've dropped one step, equals to inside the integral q. What is q? That is 1 upon 1 plus x squared, the whole square, into integrating factor 1 plus x squared, the whole dx. So y into 1 plus x squared, here you are left with 1 upon 1 plus x squared, 1 will get cancelled, and that integration is known to you. What's the integral of this? You know it. This is nothing but what? Can you just recall? It is, yes, tan inverse x plus c. This is general solution, remember. You are given certain condition here. So with the help of that condition, you are going to find the constant and finally you are going to place there. Remember. So what about the condition? As y equals to 0 when x is 1 here in the question number 14. So let's use this condition in the above one. So by 1 y 0, so this is 0, tan inverse 1 pi by 4, put x equals to 1, so c will be pi by 4 here, sorry, minus pi by 4, I'm sorry, minus pi by 4. So I'm putting minus pi by 4 there. Therefore particular solution is your y into 1 plus x squared equals to tan inverse x minus pi by 4. C will not be there, remember. You know, in particular solution we never have C. Okay. So I think almost we are through. 16 and 17, both the questions are important. So try remaining questions. Question number 18 is about standard linear differential equation, you can see. Okay. Question number 19, it's not the standard linear differential equation. Under y square hai dekho aap. So you are going to express in which form? You are going to express in dx by dy plus p into x equals to q form. So try all remaining questions. Let me know the doubts. Okay.